How is this value coming 1 minus p over p?
Yes, sir.
You're asking. So this is just 1 minus 1 over p. Like if you think carefully, what is 1 minus p over p? It is just this thing, right? It's just this thing. So if your probability like that, this is 1 over p, that is of success. So 1 minus 1 over p will give you the failure thing, right? That is what it is doing. So it is p minus 1 over p. Isn't it that way?
Can you show the PDF books? Please? One second.
So it is saying that okay, let us go over this paragraph, right? So I hope you can see the screen clearly, right?
I can see the screen, sir.
Okay. So it is saying that the hill climbing algorithm so far are incomplete. They often fail to find a goal when one exists because they can get stuck on local maxima. Random restart hill climbing adopts the well adage: if at first you don't succeed, try again. It conducts a series of hill climbing searches from randomly generated initial state, right, until a goal is found. Right. So it is trivially complete with probability approaching 1 because it will eventually generate a goal state as the initial state. If each hill climbing search has a probability of p of success, then the expected number of restarts required is 1 over p. So for 8 queen instances with no sideways moves allowed, we roughly need 7 iterations to find a goal, 6 failures and 1 success. The expected number of steps in the cost of one successful iteration. The expected number of steps is the cost of one successful iteration plus 1 minus p over p times the cost of failure, or roughly 22 steps in all. When we allow sideway moves, 1.1 over 0.94 iterations are needed on average, and 1 into 21 plus 0.06 over 94 into 64. Oh, wow. Okay, so this is 7 plus 1 minus p over p. The expected number of steps is cost of one successful iteration plus 1 minus p over p times of the cost of failure, or roughly 22 steps in all. So what is your problem? Like, what is your question? Was this asked somewhere in the presentation or
Yeah,
like?
this was asked in the presentation. Yes, sir.
Acha. Sir, we calculated expected number of restarts. How do we calculate expected number of steps? Hmm. Let us think about this. Okay, I think yes. Hmm. When we calculated expected number of restarts, how do we calculate expected number of steps? Okay. So in the PDF, it is saying that so we need roughly 7 iterations to find the goal, 6 failures and 1 success. The expected number of steps is the cost of one successful iteration plus 1 over 1 minus 1 over p. So this is 1 over p minus 1, cost of failure times the cost of failure. Now, what is the cost of failure?
I think it's the cost of failure will be number of steps in a field iteration, maybe.
Hmm. When we allow sideways moves for 8 queen is effective. Hmm. So there is not much discussed about this here also. If you see, it just says directly like the expected number of steps. Okay, is there something in the slide? Let me check the slides also. I might have that snapshot of the lecture because there's also sometimes not. Uh, we also don't go into lecture in that detail. Let's see. You can tell stop like okay. So with probability 1 minus p move to a random neighbor.
Yes, sir. This slide. Expected number of steps taken.
So here in the book it directly says it is 21 or 22 steps in all. Okay. One iteration, six failures and one success. The expected number of steps is the cost of one successful iteration plus 1 minus p over p times the cost of failure, or roughly to 22 steps. This computation is not trivial. Like this one was still trivial.
Yes,
That
sir.
okay, you need seven iterations to find the goal because your estimated probability that like you are allowed to you allow the random restart with probability 1 over p, right? The expected number of restart required is 1 over. Okay, he has a probability p of success. Hmm. Then, if each hill climbing search is a probability p of success, right? That means with 1 minus p, with every there is also a this cost of failure also attached, right? If p is the probability of success, then 1 minus p is this cost of failure. I think this is some sort of odds ratio. If you think carefully, this looks to me as some sort of odds ratio thing. Are you familiar with the concept of odds ratio in probability?
No, sir. Can you brush me up? Quick.
Let me see if I can find something relevant. Okay, give me a minute. Because that is like probability of failure over probability. So, odds ratio. So odds ratio was defined as the ratio of being presence of a two independent. If odd ratio is one, this one will be no.
This looks like recall something. Recall or
No. Okay, let me go back to that. Is the expected number of steps. It says the expected number of restarts we found that was 1 over p. The number of
P.
expected number of restarts is 1 over p because the probability is 1, and until you find the goal, you will keep on restarting, right? So number of times you will find goal is 1 by p because only then the probability will add up to 1. So this part is still clear, but I am not very sure about this part, like because I did not. I think it is not even discussed in lecture in that detail.
No, sir. It was completely skipped by the professor saying that the proof is trivial, so he will not be discussing.
The professor quoted what?
The proof is trivial. The expected finding the
This
expected number
proof
of
is still trivial. Like if anyone in the class knows how to get this, maybe you can share. Like you can share your opinion. Like I'm not very confident about this one. Does anyone else know in the class if they have tried to find how this is true, or like, because I'm not very confident on this. Expected number of steps is the cost of one successful iteration plus 1 minus p times divided by p, the cost of failure. Expected number of restarts is 1 over p. So, yeah, this is that. So, 1 by p minus 1. I'm not sure about this. Like, I have never gone through this in this much detail, so I have no idea. Even the book also just says it very trivially. Like, maybe if you find some, if you look in some other lectures, you might find. I'll try to look it up, and I'll definitely find something by the next class. Okay.
no issue, sir. No issue.
Uh,
No issues. One more thing.
uh,
In our previous assignment, assignment number 4,
uh,
in first question,
mhm,
option number D is correct. Like is incorrect. Sorry,
mhm,
status is incorrect. But
mhm.
I think the option number D, when minimized, sorts the array in descending order. And since it's sort, it should be correct answer. It should be correct. But the in our answer list it just said that it is incorrect. Can you explain it?
No. Why are you saying that if we sort this, it will, if we minimize this, it will lead to descending order? So, what is your argument for that part?
The argument being that if there are essentially minimizing as will basically we are trying to make as zero, right? So the number of elements such that the next element is greater than the previous element is 0, right?
Mm-hmm. Mm-hmm.
If that is the case, if the next element is always is all so next element is never greater than the previous element, the array will be sorted in descending fashion, because of course, right? Because for every I, because for every I, the next I plus 1 is smaller or equal to,
Mm-hmm.
so it will sort the array, right? I think, am I making a mistake?
No, okay, let me think. So 11, if it is 10, so first element is 10, okay, and second element is 11. So AI is less than 11, so this will there. अच्छा इसमें there is nowhere written that it should be in.
Yeah, it is not ascending and descending is are not defined. Simply sorting is defined. And since descending sort is a type of sort, I think option number D should not be selected, as it is a correct answer.
But why does minimizing this cardinality would lead to the desired goal state? Like,
Yeah, desired goal still is essentially descending sort, and minimizing this cardinality will convert the array in a descending sort. As no next neighbor, the next integer is greater than the previous integer. Essentially, the first integer is the greatest integer, and the next one is slightly smaller, and then slightly smaller, and so on.
mm-hmm.
And because of transitive property, if the first is the greatest, the next one can't be, like, understand the transitive property between these greater than less than symbols. If I say like b is greater than a, then and c is greater than b, of course c is greater than a. And since the we know that the integer at I, at position I, is greater than integer at I plus 1, and we know
Mm-hmm.
that I plus 1 is greater than I plus 2, we can say that I is the greatest of all integers.
Mm-hmm. And it is
And
at the zeroth index.
yes, sir. And we can say that I plus 1 is the second greatest integer, and so
Mhm.
on.
But does anyone else also feels like that? Like, if you want to
I
add
think
something
so.
to
No, it is correct. Means it is incorrect. Means question's answer is correct. As think of it. By simply just saying that sorting, we have to sort an array. We consider that we have to sort in the ascending order. All right, because we
Mhm.
also call
I don't
reverse
think.
sort.
I mean, descending sort is a sort, man. I don't
Reverse
know.
sort what we call as descending order now.
I think
And
sorting.
when
The
we
definition of
say
sorting is arranging the number in a particular fashion.
yeah, arranging the number in a particular or lexiographic fashion, if we can say that lexiographic will always start as ascending order, I think. So it will in that terms it want ascending order, and that case means 4s equal to whatever the condition is, it is true for ascending order.
That's one convoluted way to define sorting. By the
Baki, like the first three are obviously wrong. That is clear.
Yeah, there's no issue in the first three. It's the last one. Even Bhaskar agrees with me that this is converting into descending sort. He just disagrees with me that, like, what the question is asking.
Yeah, I understood what the claim that you're trying to make is. If this becomes zero, that means the array is in descending order. I'm with you so far. I'm not saying anything against that claim. But what I want to understand is, does minimizing this cardinality, will it lead to the desired goal state if we do a local search?
That's why
Okay,
it's
so
incorrect option, sir.
That is
One
what
no,
thing
I'm
that
thinking. Like,
yeah. So minimizing s means leading it to zero. We'll get it to descending order. All right. But
no, no,
if
no, no. See. Let us assume that a descending array is a sorted array. Okay, let us assume that. Given that is fine. Like, okay, you want to sort it in descending, ascending. Any mod is fine. It can be ascending mod. It can be a descending mod. It's fine. But will minimizing this set, will it lead to the desired goal state?
I
What is
think so.
your
Yes,
thought?
sir. I think so. Reason is the transitive property of greater than less than function.
Mhm.
Because let's say, sir, let's assume an array. 3, 2, 1. Okay.
Mm-hmm.
The S will be 0 in this case.
Mm-hmm.
3 to 1, S will be 0. Now any other order other than 3 to 1 will have value as greater than 0. For example, 1 to 3 has S equals to 3. 3 to 1 has X equals to 2 3 1 will have S equals to 2. 1 3 2 will have S equals to 2. The only possible
Okay. Let's not talk. So you are saying that if array is
3 to 1.
2, 3, 1,
Okay, like this will
what
do
is
as
S
well.
here? So S is 1, right? Because only
Uh,
2 is less than 3 and 3 is less than 1, that is not correct. So the cardinality of S is just 1, right?
no, it will be 2, right? Because 1
Acha, you are
1 is
assuming 0 here and infinity here, like that. Is that the case?
uh, wait a
So
second.
if 0, 1, and 2, right? Let these be the indexes. So what will be the what will be the S set, right? So see,
Okay, it will be 1. S will be 1. Okay, okay.
A0
Unless we
is less than
assume.
A1 and A1 is less than A2. This is what you will check. So is A0 less than A1? Yes. So
Okay,
you will put 0 or 1 if
okay,
your indexing starts with 1, depending on however you index it. So your cardinality of S will be 1, right? In this
okay, okay,
case.
sir. Right, sir. 2 3 1 cardinality will be 1. So, right.
And if it is 1, 2, 3, if it is 1, 2, 3, then
Cardinality will be 2.
the modus will be 2.
2. Okay, sir. And in 3 to 1, it will be 0.
And in 3, 2, 1,
It will be 0.
yes, so A0 is less than A1, that is false. And A1 is less than A2, that is also false. Yes, so mod of S will be 0. I totally agree
Yes.
with this.
This and as you can see that the
Mhm.
as you can see in the 3 to 1, it is sorted in the descending order, and any other case, it is not sorted in the descending order. So
Mhm.
if both maximizing and minimizing as sorts the array in some way in ascending slash descending order.
Okay, so let us think about this. Okay, so this is 2, 3, and 1. है ना? And from here what you can get? What are the states that you can get? So you can get you can get 2,
1
1,
3 2.
3. You can get 1 or you can
You
get
can't get 2 1 3. You
अच्छा
can't get 2
अच्छा
1 3.
अच्छा
You
you
can't
can
get 2 1 3.
अच्छा you can get 3C2 combinations, right? Because you can pick any
Yes.
two numbers and swap them. So you can get 2, 1, 3
Yes, sir.
because I swapped 1 and 3, right?
Okay,
Then
okay,
you
okay.
can get 1, 3, 2. I swapped 1 and 2, and the only one left is 3 and 2. So then it will be what? If I
3 to
swap
1.
3 and 2, it
3
will be
to
3, 2, and 1. So here it is 1, and here it is 0, and for here it is 1, 3, 2. So it is again 1, and here it is what is the cardinality here? Here also it is 1, right?
yes, sir.
So if you are sorting it in the descending, then minimizing it makes sense because you will
Yes.
ultimately reach to a reverse sorted state. But
Yes,
if you
sir.
are aiming for a increasing sort, so that's why it is incorrect, right? Like that. Do you understand why it is incorrect? Because you cannot say. I think this is what the tricky part was. If it is just saying that it will lead you to the goal state without describing what the goal state should be.
I do
Like
understand.
if it says here for s equals to this, minimizing mod s might lead to the desired goal state of finding a descendingly sorted array. Then it is correct.
So you are saying like the source, a descending sort is not a sort?
No, I'm not saying that descending sort is not a sort, but I am saying that that statement is not complete. This statement should include that what is the type of goal state you want. Do you want a ascending order state or do you want a descending order state? This might not be true for this might not be true for a ascending order thing, right?
But but I think both ascending and descending sort are the goal state. There can be multiple goal state, right? And since we
No,
are
but
not,
then it should. No, no. See, these are n distinct integers, so there will be only one goal state.
no, there can be many goals still. 3 to 1 is a sorted array. We want to sort an array of n distinct integer, right? So 3 to 1 is a sort, 1 to 3 is a sort. There are
Huh.
two goal state.
There are two. Yes, exactly. But that depends on the exact definition.
Yeah,
That
but the
what are you
question is, yeah.
what are you considering as a sorted array?
So it depends, right? I think descending sort is a sort. I mean,
Let's see. Yeah, I agree with you that a descendant, an array that is sorted in a reverse order is also a sorted array. That is fine. But I think in general, it is assumed that it is ascending.
so the question should be more well defined, sir.
But yeah, I mean, in general, like if you are familiar with competitive coding domain or anything, so there if there's a sort an array, they generally mean that it should be sorted in an ascending order and not in a descending order.
I mean,
Because if they want the array to be sorted in a descending order, they generally will ask, they will definitely say to sort it in a reverse order. In general, like in practice, if you say sort, that generally refers to sorting in ascending order. So you can discuss this in your channel. I think that you might have
the
with
channel, nobody responds in the channel, sir. Nobody responds. Nobody, like,
nobody,
even if you look at the first messages, like, there is no response from the officials.
because like we don't meet with the prof. Like we only do this independently. So I cannot take your like these type of queries to the team. I can only help you with this process, but I cannot take your queries anywhere because we don't communicate with the professor at all. So I'm not the right channel to discuss these kind of logistics. Like, so
Yeah,
who are the normal TAs? Like, are there any normal TAs for this? Like teaching assistants that help you or no? There are no sessions
um,
as such or no TAs.
I've only taken Joy of Python class,
Hmm.
and where in the Joy of Python, if we said like there's some answer, like in there were many wrong answers. Like the answers that were given by the professor were wrong, and if we tell the TA, they've just generally in the next after next assignment, we would get bonus marks for those
Hmm,
things
hmm,
of
hmm.
those questions.
Exactly. Yeah, I can understand that problem.
But here in the AI, no one is responding in the Google groups,
Hmm.
which is I don't know. In some other cases too, like I have taken other courses. There are
Hmm.
also like there's some issue like sometimes the answer would not even present, and like absurd answer, and like and there were same answer like two options, the same
Hmm.
options, and one of them was like correct. Like if the options are the same and you tick
Hmm.
one, and it's like a single choice option, and then at the deadline they will say like the option is correct and the C option is correct, but B and C are the same options, and there are some issue of other courses as well.
Okay, so in that case, I can talk to the NPTEL team. Like maybe I can push your query to them. But like from my side, I can say that in general practice, what we assume when you say sorted array is it is sorted in ascending order. Like that is a general practice.
I understand, like, but it is not defined, so that's why I said like
I understand your
I
concern.
just checked one thing, sir. That
Mhm.
I just posed the same question to ChatGPT, and it totally agrees with surname. Means I'm just pasting the answer of the ChatGPT in the chat box, so you can see. Means it is also giving the same example, same reason. I can't,
yeah, great minds think alike.
uh, or perhaps you are also standing on the soldier of
So what is the
giant.
case? Like consider the case we have. So what is that case?
Yeah.
So I just posed the same statement and asked each is correct or not.
Mm-hmm.
So it said that contains the this is let me see that have I posted the correct its response. No, I have posted the wrong response. Just a second. Yeah, now it's the second message which I have sent. I think whole message is not going in the chat box. I should
And so you can just
divert
post
that.
the rest or the remaining half. As even I am interested to know that what is the case it has generated and is it
Yeah,
correct or not.
let me
I don't think
divide
ChatGPT
it
is
by
very
part.
good with
No.
mathematics.
Yeah, I also think the same, but this time it agrees totally with you. I'm just segregating by full stop so that I can send the answers
However,
half
nowadays
by
there's
half.
not necessarily the rule, it is a sorted array. Yeah, because like if you see in here, we did like if we maximize or minimize this, uh, if it is zero, that means it is a sorted array in reverse order, and it is the least possible value. So obviously, minimizing this will take you to a condition where the Acha, but it is n distinct integers or what?
Yeah, and distinct integers, sir. There are no duplicate integers.
I
Okay. So
pasted the chat GPT's response
for
and
the
it is
case of positive three things, it might be correct. But what about if the numbers are negative? Have you thought about that corner case?
I don't think it would make a difference if the no, even if the numbers are negative. It doesn't matter.
In this case, S is one. Huh? We already solved. We solved this question on this same example.
yes, sir. That was trivial thing which I thought. That chat GPT also came up with same thing. So either great minds think alike or someone is standing on the soldier of giant
No,
which
I am
giant
not
will
standing on the shoulder of giant. And full
so
disclosure here, I
so
don't use
both
ChatGPT for mathematics. Like I'm going to be full
so
Number of
disclosure.
variables in local share and distance from the goal state. So how do you evaluate the distance from the goal state? Like
so
by the
I
number of elements that are not in their correct place, like
No, I think that will be the number of swaps, right?
or it can be like how many number of swaps are needed to get there.
Yeah, that will be a true distance. The number of swaps needed will be true distance, and number of misplays would be like a heuristic, which was asked in the last
Mhm.
previous to previous week.
Mhm. Yeah, even that heuristic was not bad.
Yeah, it was pretty good actually.
Yeah. Okay.
now
So
I'm pasting the further and
there is a third part also.
yes, part four, and you will see that it is also saying the same thing that question should have specified that either
Yeah,
ascending or
that's what I am
descending.
saying. That statement is, in my opinion, it is incomplete and hence wrong.
Which
See,
was quite
why I'm arguing it is wrong is because the statement itself is not complete. That is what I'm arguing. Because I
mhm.
don't think the statement is complete. It clearly mentioned that it leads to the desired goal state of a sorted array in descending order and of a sorted array in ascending order. Something like that. Some sort of uh, uh, positional argument or something should be there. Like this is the stance that I'm taking. Like that is not given. Anyways, I think this is just a confusion, not more on the.
I don't think like it's a it's a language confusion. Like we are
Yeah,
there is
yeah,
ambiguity in the question itself.
it's a language problem because see if you can find a corner case where minimizing this might not lead to a sorted array, then I am with you on this. So can you think of a corner case because it says n distinct integers, right? So if there are some if there are some cases where there are like negative integers or zero or something like that, will it
No, sir.
affect?
No, sir. It won't affect because because the greater than symbol does not matter. The greater than symbol does not give like weird corner cases with negatives or zeros. Right? The greater symbol is pretty clear. And since we are already said distinct integers, I don't think
Mm-hmm.
the equality even matters.
Mm-hmm. As I was saying, even if it is 2, 3, minus 1, if we think about that, so
So if it's 2, 3, minus 1,
let's
uh,
just think for the time being. So what are the states that you can get? You can get 3C2 state. So first let us swap this, right? And 2 is less than 3, 3 is less than minus 1, no? So still the cardinality of S is 1. Okay. So if we swap minus 1 and 3, we get 2 minus 1 and 3, right? Here also cardinality of S is 2 less than minus 1? No. Is minus 1 less than, is 2 less than minus 1? No. Is minus 1 less than 3? No. Oh, sorry. Minus 1 is less than 3, what I'm saying. Sorry, my bad, my bad. So here the cardinality of S is 1, right? And if we swap 2 and minus 1, we get minus 1. If we swap 2 and minus 1, we get minus 1, 3 and 2. So is minus 1 less than 3? Yes. And is 3 less than 2? No. So mod S is 1. And the third swap will be 2 and 3, right? So it will become 3, 2 and minus 1. So is 3 less
This
than
will
2? No. Is 2 less than minus 1? No. So here mod S is 2.
no modulus is zero.
Oh, sorry, mod S is 0. Ah, yeah. So uh, that is your point of failure, right?
Now that is the point of success because we
हाँ,
reach the
मतलब,
desired
that
state.
is a point of success, yes, but considering that it is in descending order,
Yeah, yeah. I don't think there's much worth. Like it's a language
it is a
thing,
language
no,
problem.
no, not mathematics thing.
ठीक है,
No.
so we can move on then. Okay. Then our second question is, or I think we discussed this in the doubt
Yes,
session
sir.
class itself.
Yes, sir.
Oh. And which of the statement is so? Does anyone want some analysis on this, or we can just skip past question number 2? Okay, I'll just quickly say. So, local search through random sampling is not asymptotically complete because it takes a lot of steps. Random walk with restart is asymptotically complete. We saw that right now in the book I just shared with you. Hill climbing is not asymptotically complete because it gets stuck in plateaus or local optima. That is correct. And to get rid of this, we have taboo search and all the algorithms like that. And the last one, hill climb with sideways moves, is asymptotically incomplete. The answer is incorrect because it might still be stuck in a local optima in case of an infinite loop, right?
So
So it is.
taboo search is also not asymptotically complete now.
Hmm?
Taboo search is also not asymptotically complete now.
If
Taboo
hill
search
search
with
is
Ah,
infinite
no, I'm just saying that
sideways
the
moves.
hill climbing with sideways moves is asymptotically complete. The answer is no,
Yeah.
because we saw last time that if we allow infinite sideways moves, right? It is not guaranteed that it will get you out of a local minima. If you
Hmm.
remember, we read somewhere here only that yeah, might it not be a good idea to allow sideway moves in the hope that plateau is as a shoulder? So I hope you can see this argument, and you might also remember that if you were present in the last class. So might it not be a good idea to keep going to allow a sideway moves in the hope that plateau is really a shoulder? The answer is usually yes, but we must take care. If we allow sideway moves when there are no uphill moves, an infinite loop will occur whenever the algorithm reaches a flat local maximum that is not a shoulder. So one common solution is to put the number of consecutive sideways moves allowed. In this example, it is given 100. So this is just an argument to say that it is not asymptotically complete, which was also covered in the last class. Anyways, okay. So the next question is, which of the following statement is correct about temperature in simulated annealing? Right. So let's take the remove the one which are incorrect. So it is increased. So the temperature is never increased over time. So these two are wrong, straightforward wrong. The tendency to remain at local optimum increases with an increase in temperature. This is also wrong because initially you keep high temperature with the aim to take bad steps, and the intuition is that okay, at first you can keep on exploring as much as you can, and then once you find a good solution, you just uh, you just explore its neighborhood. And that's why if the initial temperature is set too small, the search can get stuck at a local optimum. So it follows from the argument of this, like if the reason why we keep the temperature high in the initial phases is to get out of a local optimum situation and start climbing the hill in a positive direction. This was also discussed in
The last session, yes, sir.
the last session. Yeah. So identify all the differences between simulated annealing and genetic algorithm. So this this one is correct because GA maintains multiple candidate solution. If you remember this slide uh, here,
The
the
last slide.
genetic algorithm is indeed maintaining lots of candidate solutions, whereas GA only takes one neighboring state and it goes there, right? Simulated annealing takes only one goal state and it takes that and explore its neighborhood. GA provides stronger guarantees, so this is nowhere true because uh, we have no idea about this part whether it is correct or not. SA has no parameters to set, whereas GA requires you to set multiple parameters. So SA has a parameter which is the temperature, which was discussed in the last session. So essentially, whenever you're doing simulated annealing, you need to give a temperature schedule. So you do need to set that parameter in order to conduct the steps of simulated annealing. GA will always converge to an optimal solution faster than SA on any given problem. So this also does not seem correct because there are no bounds or there are no bounds or part of discussion was not even considered that is it faster or is it slower. So there is no point of discussing that anyways. Mm, what is the next question? Yeah. So, which of the following optimization objective will convert a constraint satisfaction problem to an equivalent optimization problem? Minimize the number of constraints satisfied, maximize the number of constraints satisfied. So here, assuming that it is a maximization problem. So, were you guys also? Did you guys pick minimize also?
No, I did the wrong. I did the right. I chose the right answers. The B and D.
So this was also covered in the lecture, like if you maximize the number of constraints satisfied, then it becomes an equivalent optimization problem. Maximize R where R is 0 when all constraints are satisfied and 1 otherwise, and maximize R where R is 1 and all constraints are satisfied and 0 otherwise is the correct wording because if you want to maximize R and if R is 0 when all constraints are satisfied, so it will become a negative case and it might not be true. So maximize R where R is 1 and when all constraints are satisfied and 0 otherwise will convert this constraint satisfaction problem to an equivalent optimization problem.
Sir. So in this question also, it is not clearly mentioned that it is minimizing or maximizing means.
Okay, so I
So
think
it's
in context of like whenever you are trying to solve these questions, just stick with whatever was discussed in the lecture. So in the lecture when this part was discussed, it was I think
He had
more on
clearly
the
stated
optimization
that
problem.
we should maximize it. He had stated it, I think.
So that's why I think it makes sense, right? Maximize the number of constants satisfied. And
Mm.
anyways, I think if you minimize the number of constants satisfied, how can you convert it to a equivalent optimization problem?
yes, sir. Like I think that it's not
Yeah.
context
Okay.
dependent.
I
It
mean,
is clearly mentioned that minimize the number of constraints
yeah,
satisfied.
yeah. I mean,
If
if no constants are satisfied, anyways, you will not reach the goal state, and
Got it,
hence
sir.
it
Yes,
will
got
it will not optimize. So yeah, maximize the number of satisfied constraints will definitely convert this problem to a equivalent optimization problem. Okay. Local beam search, so discuss fine. Acha, how many of you responded 7 and 8 correctly? Maybe just a show.
I
Sir, I maximum of.
Hmm?
Sir, I have.
Okay. So you can just raise
uh,
your hands. Like if many of you were able to, then I think you might have also shared your responses within that group or something. Or do I need
Yes,
to
sir.
solve? I don't know.
I also responded, sir, but credit goes to some of one whom you taught.
Here the tricky part was that the temperature is not zero in the last step. So
Yes, sir. Yes,
you
sir.
have to
eh,
consider that. Yeah.
Yeah.
When I saw this question when I read the question properly, I saw that the temperature schedule is not exactly similar to what we did. We did 2010-0, but here it was 10-5-1. So definitely the answers will change. Okay, so I'm not going into that much detail with that one. Which of the following statements are correct about taboo search? So it never visits the same state more than once. That is not correct. It never visits a state that is currently in the taboo list. That is true. As the size of taboo list increases to infinity, taboo search reduces to a systematic search. If that is correct, because if you remember, the idea of systematic search is that you do not explore the same node twice, right? So if you increase it to infinity, that means you are keeping all the states in your taboo list, so you will not explore the same state twice. And the last one is not correct. It is guaranteed to escape any local optimum it is stuck in. It might not be true if it gets stuck in a local optimum, which is a plateau without any uphill. So in that case, it might not escape. Okay. So and how many of you were able to solve the 10th question?
Yes, sir. I.
Assume that we have a function y. So does anyone want me to solve this one? Because I think it is pretty straightforward anyway.
s-
Can you solve question 7?
7. Achha. Consider the state space having three states S1, S2, and S3. Achha. Okay, let me see. Let me recopy this. So see what it is saying. Why are there so much pages? Oh, wow, why? Can you see this question text or no?
Yes, sir.
Hmm. I don't know why I can't enlarge this. Achha, now I can. Okay. Done. ठीक है. So consider a state space having three states. So we have S1, S2, and S3. V of S1 is 0, V of S2 is 4, and V of S3 is 2. There are transitions from S1, you can go to S2. From S2, you can go to S1 and S3. And from S3, you can go to. So the transitions are similar to what we did in the class. So starting at S1, we are starting at S1. Okay. What is the probability that we end up back at S1 after two steps of simulated annealing? And your temperature schedule is 10, 5, and 1. Okay. So we take S1 here, and the temperature is 10. From S1, we can go to S2. So from S1, we can go to S2. So what is the delta E? Can anyone comment what is the delta E?
Delta is, sir, positive.
Positive, sir.
Delta is
Delta E.
positive, so we will go with probability 1.
ठीक है. So from S1 to S2 we go with probability. अच्छा, here S2 is a good state, huh? That there S2
Yes,
was
sir.
a
Yes,
bad
sir. S2
result.
is the highest
Yes, sir.
probability, highest value, sir. So
So
it will
we.
always move.
ठीक है. फिर S2 से we go. S2 से we can go to S1 or S3.
Yes,
Yes,
sir.
sir.
S2 से we go either S1 और S3. अब यहाँ पे probability वाला फंडा आ जाएगा.
Yes, sir. Uniformly chosen as, sir, 2.5 probability for each path
No,
into the
sir.
probability
नहीं
of
नहीं
that.
नहीं 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 नहीं
0.5 times
Point five
the
times the
probability.
probability, sir.
नहीं नहीं.
Yes, yes.
एक सेकेंड. The what was delta E? So
Delta E for
So delta
S2
is
will be
2 and 4, sir.
अच्छा एक
So delta E for S3
negative.
is 2.
एक
and
second.
delta E for S1 is -4.
एक second. So from, अच्छा, this is the simulated ending. Okay. So delta E is the value of next minus value of current, है ना?
Yes, sir. That is the -2 and -4.
तो वहाँ डेल्टा ई लेस देन जीरो हो गया तो 0.5 की प्रोबेबिलिटी से वी विल नॉट गो, राइट?
No,
Sir,
sir, we will have
0.5
the
into the
probability of
probability of
selecting.
that which calculated the stimulated annealing
The probability
probability.
of
अच्छा अच्छा,
selecting
दैट यू आर
probability
सेइंग.
of selecting S3
Yes, sir.
is
Yes, sir.
0.5.
ठीक है ठीक है ठीक है ठीक है.
Actually, it could both paths are chosen equally, and we have
हाँ
to
हाँ
go
हाँ
to
हाँ,
S1.
ठीक है ठीक है ठीक है. सो दिस इज 0.5 into e to the power that minus delta e over t factor, right?
Yes, sir. -4/5. Temperature is 5 now, sir.
Hmm. So in this case, if we pick S1, what is the delta E? In this case, it is minus
Minus
4. And in this case, your delta E, if we pick S2,
-2.
it is minus 2. And your temperature
Yes,
is 5. Okay.
5. Yes, sir.
So 0.5 into e to the power minus 4 over.
-4/5.
So what
That
is this
is
value?
0.225. Yes, sir.
वही
0.225.
तो है
This is the
आंसर.
answer.
वही तो है आंसर.
Yes, sir. Yes, sir.
That is the answer.
Yes.
No, sir, no, sir. We have to consider that that S2 will not move to S3 or S1. S2 will remain in S2.
Nah, it's
No,
simulated.
Yes,
no.
sir.
This is the
Yes,
answer
sir.
of first question. First question, sir. This is the answer of
Okay, answer first question is.
You told me to solve 7, right? So I'm solving 7.
first question. Or seventh question. Sorry.
Huh. You told me to solve 7, so 7 is just to find what is the probability that we will end up back at S1 after
Yes,
two
sir.
steps. So
Perfect, sir.
after first step we landed at so after first step we landed at S2, and back to S1 we will go with probability 0.5 into e to the power minus delta e by t, which is uh, minus 4 by 5, not minus
Yes.
delta e by t, but like e to the power delta e by t. Sorry. So this will be e to the power delta e by t, and this will also be e to the power delta e by t. Yeah, that is what is mentioned in the slide. ठीक है, तो इसके बाद क्या हुआ? What was the confusion?
Nothing, sir.
No, no. Who was, is the doubt now clear? Like whoever was asking, is the doubt now
Yes, sir.
clear?
I didn't multiply zero point 0.5.
Acha, you did not multiply 0.5. Okay. See, you need to do that because you can go to each of these paths with a probability 0.5, and then you also pick these states with some probability attached to them. So,
Sir, can you explain once more, sir? I couldn't understand.
sure, sure. See, the idea is for the simulated annealing, right? What do we do? Let me go back to the slide. Okay. Can you see my screen? The simulated annealing slide?
Yes, sir. Yes, sir.
See it? No? So
Visible, visible.
what we do, first of all, we pick the schedule. First of all, we pick the temperature of the schedule. Then we check if T is 0. If it is not, then we return whatever we have as the current state. Otherwise, we pick a randomly selected successor of current as the next state. Okay. Now we will go to the next state with a fixed probability of 1 if and only if we find that it is a better state. And how we identify that? We identify that by the concept of delta E. So this delta E will basically give you value of next minus value of current. Okay. Now if this delta E is greater than 0, then you pick the current state, then you pick the next state as the current state, which is what we did here. So if you see between S1 and S2, what was the value of the current state? The value of current state was value of S1, which was 0. And what was the value of next state? The value of next state was the value of S2, which is 4. Right? So delta E will be 4 minus 0, which is 4. So your delta E is greater than 0. That means you will pick the current state as the next state. So your next state will become the current state, which is सॉरी, मतलब वो थोड़ा सा इसमें देर इज आई माइट हैव रिटन इट रॉन्ग, बट या your current state will become the next state which you picked randomly, which you picked from the successors of whatever you had, Otherwise, if this state is a bad state, you still take that path, but with some probability, and that probability is calculated using this formula, e to the power del e by t. So this is what we did in the second part, when we found that from S2 we can go to S1, and from S2 we can go to S1 and S3, right? So each of these children can be picked at random. So because the question says that I think the question states that the children, the successors can be picked at random. There was some wording there. Assume that we follow temperature schedule. The next state is chosen uniformly at random. If you see this part, it says that the next state is chosen uniformly at random. So if there are two states, we will pick each of them with probability 0.5, 0.5, right? Is this clear? That why we keep 0.5 here? Is this idea clear?
Yes, sir.
And then so we pick them with 0.5, 0.5. Now now we see that whether these are good states or bad state compared to the current state. So we find that both of these are bad states because their delta is less than 0, right? So what the simulated annealing says, it says that you still pick you still pick that state, but with probability e to the power delta e by 2. So if we pick S1, if we pick S1, we will the probability of picking S1 is this 0.5, which is the probability of picking S1, and then making it as your current state is e to the power minus del E by t, where your minus 4 is del E and 5 is the temperature. So that's why it is 0.5 into e to the power minus 4 over 5. And that gives you your answer, which is 0.225.
So can you explain the next state also?
I think this was okay. So in the previous question, what is the probability that the simulated drilling terminates at a state with highest value? Assume that the run terminates after 3 steps. Okay. Okay, so let me then write this very clearly because we were getting lost here a lot. Okay, so from S1, you can you can go to S2, and that you are doing with probability 1. From S2, you can go to S1 and S3. And can someone tell what are the probabilities here on these paths? So this one I know it is 0.225, which we got from above. What is the probability of going from S2 to S3? Can someone compute and tell me that? Because it is again 0.5 into e to the power delta E by t. So what is that value? So did anyone solve eighth question? Question number 8 or no?
Yes, sir. I solved it, but I don't
Yes,
have
sir.
it written.
Yes,
Uh-huh.
sir. I have solved and my answer was right.
So what is the probability of going from S2 to S3? I'm just writing it here. It is 0.5 into e to the power minus 2 over 5, right? If I'm not wrong.
Yes, it's right.
Hmm. So what is this value?
This was actually one. Just wait, sir.
Okay, anyway, so from S1 you can go to S2, and from S3 also you can go to S2, right? So from S1 you can go to S2, and S3 you can go to S2, and this was your third step, right? So I see in both the cases anyways you are ending with
It is
the
0.335.
No, no, sir. One case
Sir,
will be
you have
the
not.
sir. We
Sir, you have
we go
not
to S2
considered.
and we will not go next, sir.
You have
We will
not
remain at
considered.
S2.
from S1 to S2, from S2 to S1, and S3, and from S3 to S2. Now
Sir,
starting
sir,
at S1, what is the probability? अच्छा ये तो ये वाला question हो गया. हाँ. Now what is your argument?
sir, there is a probability that we will not move to either S1 or S3. We will remain at
We will
S2.
remain at S2, sir.
That is 1 minus the probability of moving from S2 to S3 and S2 to S1. There will be
Okay.
probability where we remaining at S2 itself.
ठीक है, so you are saying that is this path with these probabilities.
Sir,
Yes,
is
sir.
it
One
necessary to
minus.
include this condition also? It will remain, I mean, it will
At,
not go to S1 or S3 from S2, and
at
it will
any
remain in
at
S2.
any cost, sir. This will remain at S2 after three steps, sir.
Hmm.
It will not go further.
ठीक है, so
So we have to consider the three conditions, sir, three paths.
hmm,
S1 to S2, S2, S2. Three times, sir, it will remain at the S2 and two paths which are equally probable.
hmm.
I mean, it will stay at S2. I mean, then in that case, the path will be S1 to S2 to S2 to S2.
No, no,
Because
just
this
S1
is,
to
I
S2
mean,
and then S2 to S2, like just.
again, so three, I mean, so because the entire thing terminates in three steps, that's why you are writing, I mean, S2 to S2, again S2 to S2. Is it that way you have to
Ha
think?
ha ha. See, because like this is what you get at the first stage, this is
Yeah.
what you get at the second stage, and this is what you get at the third stage.
Okay.
So I
But
think
why it will not stay in S2 with probability 1?
no, no, it will not stay because see,
From S2 to S2 itself, if it is going to stick to that state, then, I mean, I don't know. So this is not clear. I
Then
mean,
no, no. So
what is
here
the
also,
necessary to recalculate that? If it is going to stay in the same state, what is the purpose of recalculating again?
yeah.
In the second step, there's a there's some probability that it will remain, and the third state, in the third step, there is also a small probability that it will again remain at S2.
in each of these cases, you will compute these probabilities.
Yes, yes.
It will not be that it will just go there.
Yeah.
You will go to S1, S3, and S2.
That means it will be 1 minus the addition of all these probabilities that you are getting
So 1
for.
minus these S1, S3.
Yes,
Like
yes.
if you don't take any state and if you plan to stay at S2, so you will do with that probability. So I
Yes,
think only then the entire probability will be 1.
yes. Otherwise, it will not be.
Otherwise it will not be 1.
Mm.
Yeah, I think this was the point of confusion in the last class that we did not
Mm.
that we were not able to get
Yes,
out.
yes, yes. Mm.
But in the book, does it says that you can be there? Like,
Yes, sir. Yes, sir. If, for example, I calculated the previous year's exam, previous year's assignment, and I actually calculated, and this way it reaches the right answer. And in this year's assignment too, by this method, I calculated it again, and I got the correct answer this way too.
yeah.
And in the book also, it is stated, right, that there's a small probability that it will move, and the rest of the probability will not move at all.
कहाँ पे लिखा है?
Sir, in the algorithm itself, it is written.
अच्छा, in the book, in the algorithm, it is written like that.
Yes, sir.
अच्छा, so
Oh, this algorithm, yes, sir.
Sir,
So
if
with
we will
only
not
with
move,
probability.
sir, if we will not move, then what is the purpose to stimulate the annealing?
no, no,
We
no.
have to move with some probability.
That is what even I am confused. So that's why I'm asking that what is your source of information that you
Yeah,
are.
Yes, sir,
yeah.
the
So
algorithm
exactly.
clearly
From the
says that,
algorithm, it's, I mean, nothing is evident from this. The algorithm states only this thing.
yes, sir. So if the delta is greater than zero, then the current is of course in the next. Else current becomes the next state with probability this. If this probability does not happen, then of course that nothing happens, right? If e to the power minus c by t probability event does not happen, then then nothing happens. No action is taken place. That will remain at the same state, right? In the algorithm, since the so total sum of probability must be one, and there's a small probability that will be moved to a different state, then the rest of the probabilities that we don't move at all. I think that's
See,
self-evident.
my concern is that see whatever you are saying from point of computation. to make it complete, right? To make a computation complete. But is this correct?
I think so.
Then sir, there will be
A
self
time.
looping in any at any particular node. Any arbitrary node also we can have a self
No, no.
looping.
So, okay,
No,
let
not
us.
an arbitrary node because the line, the else statement is only applied when we have the next all states, the selected state is actually have lower value than the current state. If the selected state has a higher value, then we move to that state with the
No, that's
probability of
true.
one.
That's true. But always from S1 to itself, there is a possibility. I mean, if this is true,
S1 to
means
S1 is not possible because S2 has a greater higher value than S1.
no, no, that is correct. What I'm saying is, if you are at any particular node, then self looping is always a possible state.
No, it is only possible if the selected node has lower value than the current node.
No, no. What I'm saying is from S1 to S1 itself.
No, S1 to S1 is, cannot happen because
Okay,
S2 has
so
higher value.
what? So I can clear the confusion here. So what he is saying is that if you are in this condition, right? If you are in this condition, when your next successor is better, you don't do self loop. But if you are in a condition where your next successors are bad, right, then you can consider doing self loop.
Oh,
And
is
the
it like
reason
that?
also makes sense. The reason is that why would you even consider going downhill if this is the best?
Yes, sir. Like we would wait for the temperature to end, come to zero, right, sir? If we are already at
I understand your
optima.
intuition now. See, I understand what you are trying to say, but there are no such comments on the algorithm. So I am not very sure that whether it is correct or whether this is what is actually happening or not. But I totally agree with your intuition that okay, if with e to the power delta e by t probability you might pick bad state, or with the remaining probability you might decide to stay at the same state, assuming that you will not find a good state. See, if you find a good state, then anyways you will not continue this path any longer. It will not make any sense. But then my natural question would be, we are not maintaining a lot of successors. We are not maintaining any candidate solution, right? As opposed to genetic algorithms where we are maintaining candidate solutions. In simulated annealing, we don't practice maintaining a candidate solution thing. So, is this approach correct? Is this what is actually happening? That will be a natural follow through.
Sir, wait a second. So, sir, in the algorithm,
Hmm.
for example, if nothing happens,
No, it see that is the point, that it's not the case that nothing will happen. See the innermost. See what does the book says? The book says that the innermost loop of the simulated annealing algorithm, which is shown in this figure, right? What does it does? Is quite similar to hill climbing. Instead of picking the best move, however, it picks a random move. If the move improves the situation, it is always accepted. And how you ensure that the moves improve the situation? Simply by stating delta is greater than zero. ठीक है? If your delta is greater than zero, then you go there. Done. Otherwise, the algorithm accepts the move with some probability which is less than 1. And that probability is e to the power delta e by 2. But here it clearly says the algorithm accepts the move with some probability.
yes, less than one, right? So it doesn't always move. The rest of the time, it will stay where it is. I think it's an obvious conjecture. Like if something happens with the probability of less than one, then the rest of the time it does not happen. I don't think I'm making a big leap there.
Now then you need to go back today and check that
The
will.
answers are right, right? I'm
हाँ,
getting the right answer with this algorithm.
आंसर्स तो ठीक है. I'm saying that your intuition is coming from the answers, which is not totally wrong. But then is there any theoretical backing to it? That is what my uh,
I think like if you're already at local optima, I think the intuition, if you understand like what the algorithm is trying to do,
see,
it becomes obvious.
I totally understand what you are trying to say. So essentially, what you are trying to say is as follows: like, if from a state I go to a good state and all the neighbors of these good states are bad, then why not just stay here? In one of the branches, why not just stay
Yes,
here
until the temperature ends.
until the temperature goes to zero?
Yes, sir,
That
exactly.
I understand, and I agree that yes, this might be correct, and I think that this might be correct. But but why I'm not betting my money on it is because I have not like I don't see any supporting evidence in the book itself. The book does not says anywhere that like you can just stay there. So what you might do today is like after the session ends, you can go and check some other books or maybe some other lecture series online. That might help you to get the to get answers to such questions. I totally agree with your intuition. I'm not saying that your intuition is not correct. But what I find hard to digest is that is this how actually simulated annealing works? That is where I'm facing some issues understanding that part. Okay, so can we start with the this week's questions then?
Yes, sir. Previous year's questions.
ठीक है, ठीक है. Does anyone else have any other question to ask or like any comments to make? I don't know. The seventh I did. I think yeah. Someone asked that can you solve seventh? So seventh we solved. We got the answer 0.225. However, for eighth,
Sir, one thing I want to ask, sir, in the last year assignment, I have given the answer just like 0.606 and the answer was 0.607. Then it was given me wrong.
no, it was
And you were saying,
0.606 only. No, 0.606 only.
no, no, sir. In the last year assignment, in the same assignment 4, just like the simulated angling question, I have written the answer 0.606. And finally, when the answer will come, then that was the 0.607. And my answer was given the wrong number.
No, in week four, what? No, in week four, it,
Last year, sir, last year assignment, sir. You were saying the precision will, the value between zero point 0.6 or zero point 0.7 will be taken as right,
no,
as
no,
your
no.
professor.
I see. No, no, no. What I said was that normally, so when we were made like when we had this orientation session of this NPTEL TA ship, so there they told that whenever it is numeric, it is better to give a range instead of fixing like the exact answer. But if it is saying that round the answer to three digits after the decimal place, so what was the answer? Was it 0.6069 or it was like what was the answer like?
So my answer, I have written the answer 0.606, I think 5, 0.6065. And I
Like
have written the answer
what was the four
0.606.
five digits? Like if you remember that significance thing, so it should be rounded down to 0.607 only. But Niva, अच्छा, okay.
Yes, yes, sir.
You're the one you're speaking. Oh, ठीक है. So I think uh, normally it is a practice to keep the range, like like the professor can keep between 0.605 to 0.608. Uh, like normally this is what we are. This is how it was given to us, but that ultimately depends on who is setting these problems. So I have no
But sir,
control.
last time my both of the answer were considered wrong for the 0.001 precision.
Actually, I don't set the answers to this question again, so I have no idea. But when you were having that orientation session, there it was mentioned that it is always a good practice to mention a range, like so 0.605 to 0.607, something like that.
Sir, again, I have a question. If you go from S2 to S2 itself, then the change in the evaluation function, that is again 0. So e to the power 0 by
No, no, no,
something.
no, no, no. It will that see the idea is if you go from S2 to S2, like then there is nothing. Then you just stay here with this one minus the probability, because see you did not go to any of these paths, right? So you will stay here with one minus the probability of going to these paths. So it will be 1 minus e to the power 1 minus e to the power minus 2 over 5 minus uh, plus e to the power minus 4. So
Yes,
whatever
sir, that
that is.
can be calculated. That can be calculated into point 0.5 also. You have to 1 minus point 0.5 into this thing. That will be the probability for staying in S2.
So is that point clear? Is this point clear? Like,
Yes, yes, that is the way to calculate. Otherwise, it will not be the correct answer, I think. I was thinking that way because since it is staying in S2, so the change is delta E will be maximum, I mean 0 by T. So that way I was thinking that will have the maximum probability, but it's not that way, right?
so you're saying in question 10xn plus 1 becomes 0. So do we consider it for convergence or not? So does it does it happen like that? Let me see.
So convergence is supposed to happen at 1, not 0. So it doesn't matter.
So y equals to x minus 1 to the power 4. So what is the maximum value? What is the uh,
Minimum, we are supposed to find
0.25.
minimum?
minimum.
0.25 is the maximum value, sir.
So it will be 4 into x minus 1 to the power 3 equals to 0. So that will
Yes,
be
sir.
x equals to 1. So if you remember the funda, like if you are given f of x, then your minima will can be obtained. Your optimum points can be generated by doing this equation, right? F dash x equals to 0, and then checking whether f double dash x is less than 0, greater than 0, or equal to 0.
Yes, sir. Yes, sir.
If this is the case,
Ac-
I think it is maximum. If this is the case, I don't remember the exact terms, but yeah. So here only one point is there, and that is obviously the point of minima. And so x minus 1 to the power 4 will look something like this. Or sorry, I drew it the other way, but yeah, at
Sir,
x
we
equals.
can solve it also and mathematically, sir.
Yeah, yeah. So your f dash x is your f dash x.
Sir, minimum is occurring at 1.
Minimum is occurring at 1, right? So yeah, x equals to 0 will not be the point of convergence. That is what we are arguing. Yeah.
And in question, it is given that we have started at x is equal to
2.
2. Yes, sir. For this, we are getting the value of lambda equal to 0.25, and that is the maximum value. We will give the that value and the minimum of that two value, zero point
No,
0.2
no,
and
no,
zero point zero 0.05.
no, no. You cannot. Uh, matlab, acha, you are directly going with that. Like if you, so you have to go to one. Acha.
Yes, sir. I am going to 1, and this will start from 2, and then 2 minus lambda into dy by dx, and I will
I
get the
think
value of lambda as
So it will be
0.25.
minus lambda
uh,
times 4
I
into.
think
Yes.
the actual value will be slightly greater than what we find through here, because even we overshoot one by a little amount, like if we get 0.999 something, we can still converge to one in the next step. So I think the value should be slightly higher than what we will calculate through the method proposed by my Rajni.
Essentially you have to like check for this equation. So okay,
Yes, sir.
if you're starting at 2, right? So what your xn plus 1 will be? So it will be 2 minus lambda times
For
2,
2 minus 1.
which is this, and
Yes, sir.
this cube. So it will be 2 minus 4 lambda,
Yes,
right?
sir. And the minimum value of x is equal to 1.
वो ठीक है, वो don't go exactly there. See, I understand your approach, but you have to do it systematically. Like,
But I think sir, that will be the maximum value of lambda, na?
No, I think the actual value lambda will be slightly higher, because even if you overshoot, like if you got 0.9999 something, in the next step we can go to one again, right?
see, essentially, you have to keep lambda such that your xn plus 1 approaches 1. That is what the so for all those values of lambda where your xn approaches xn plus 1 approaches 1, those values are acceptable. See, so what all values did you have? Can someone tell me what are the values of lambda in the option?
Yes, sir. If you take point 3 by 4, then it will quickly oscillate. I mean, it will jump to this side. Similarly, point 5 also the similar case. And if
What
you
are
take
the
these two, point 2, it will take considerable time, and point 0.05 will be still, it will still take more time. So these two are the correct options only. Point 2 and point 0.05.
अच्छा 0.05, 0.2, 0.5 and 0.75 ठीक
Sir,
है.
point 0.5, 0.75 will never, I mean, take.
Yeah, it diverges actually. It diverges, goes away from the solution.
It will also oscillate, sir. It will jump to this side. If you start from 2, then it will, instead of going to this side, it will jump to the next.
ठीक है, that we know. So for this particular one, अच्छा, if we keep 0.5, so it will go to 0, and then again it will become 2
Two.
plus 4
It's zero
lambda.
to zero to isolate, sir. It isolates from 0 to 0 to.
Sir, we can put also the extreme cases also, na sir? We can put value 1.
And that you can put, but that will give you the bound on lambda, I think, more or
Yes, sir.
less.
Matlab that will be the maximum value, I think.
Mhm. Yeah, that is because like in this case you are able to find a closed form solution for lambda. Where normally like in general you'd start with a random x, right? In general you start with a random x. Here since your xn is given that okay your xn is 2 and you start with this particular x, so you can see that okay for what values of lambda can this converge to 1, right? So for what values of lambda will I not go beyond 1? And you can clearly
Yes.
see that if it is uh, so if it is 0.05 and 0.2, it will always be less than or equal to 1. Whereas if
Yes,
it
sir.
is 0, matlab, it's mod essentially, like it will still be in that zone. So
Yes, sir. Yes.
essentially not even mod, it should 2 minus 4 lambda, it should just approach to 1. That is what we are trying to say, either from the left side or not. Okay, so but yeah, I think the basic problem was that the person understood that the minima is at 0, which was not correct. So okay, so Sumit, right? Sumit says okay, I got it. Okay, then I think we can move from this particular question. ठीक है. So for this week, there were I think 2 or 3 important concepts. Let me just quickly go over them. So this time we studied about games, and in games we studied about two state games, and the idea was of adversarial search. And for that you had states as the board configuration. You had an initial state from where you start, then you have a successor functions uh, which returns the list of move state pairs indicating a legal move, and there was a terminal state which determines whether the game is over, and your utility function gives a numerical value in the terminal state, that is whether it is a loss, win or tie. So this was an example uh, for a two-player deterministic turns for a game tree, right? So the ideal way to solve this is a minimax minimax thing. So in the minimax procedure, essentially, it is a perfect play for a deterministic game, and your idea is to choose move to position with the highest minimax value, and that is the best achievable, which is the best achievable play off against a best player. So here, if you see, so the upper triangular nodes are denoted as max nodes, in which you will pick the maximum of the successors that you have, and that is your turn to play the game. And min is essentially your adversary, which will play his game in such a way to minimize your gains, and max play, which you will play, your objective will be to maximize your gains, right? So in this case, let's do a simple run. So if you are here and you have your successors as 3, 12, and 8, and your objective is to minimize, so naturally you will pick the one with the least cost, which is 3, and you will get 3 here. In this subtree, it is 2, so you will get 2. And this subtree it is also 2, so you will pick 2. At the max node, your idea is to pick the one with the maximum cost, which is 3 here. So you will pick the 3, and this will be your answer, right? So here we have seen an illustration which is from the lecture itself. So the leaves are 80, 30, 25, 35. So from this 80, 30 we get 30, and from this 25, 35 we get 25, and from 30, 30, 25 we get 30. So essentially this is done in a depth first search setting. So from here you go to left, 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 and then you keep on pushing. And if you are at a min node, and you find that your value is the least possible value, then you don't update. And if you are at a max node and you find that your value is the greatest value, then also you don't update, right? So for example, if you are in this subtree from 20, 30, 20, so first the value of the min node will be 30, because from the left subtree the value pushed will be 30. Then you go to the right subtree again in the depth first search fashion, and from here it will be returned as 20. So your minimum value will now be updated to 20. So this is the entire idea. And then you push 20 here, and then you go to the right subtree, explore the entire right subtree, and there you end up with the value 15. And yeah, you just go up and push the value 20 as the final option. Now here, what was the problem? Does anyone remember what was the problem in exploring this full min-max tree? Can anyone comment? Does anyone remember?
Sir, yes, sir.
Mm-hmm. Go ahead.
Just like in sir, first branch, 20, 30, 30, and then 25. Here we will see that the node that the 35 is has no is extra is value. We are wasting our time in searching this because our minimum value is 25, and that should be pruned. That is the alpha beta pruning we are using for this to save our memory.
So essentially, what was happening is, if you already know that a max node, my maximum gain is 30, right? And that you push down to the successor that, okay, if you are 30 or more, then only I will pick. But
Yes, sir.
the value that you got from the first successor itself was 25. So there is no point in exploring this particular space, because 30 is greater than equal to 25, and you just prune whatever child it has, because the least value that you might get is 25, and you already have a better option which is 30, so you will not visit that. So this from this minimax, we then move to the concept of alpha beta pruning, where you can speed up a depth first minimax search, where alpha is a lower bound on the value that a max node may ultimately be assigned, and beta is an upper bound on the value that the minimizing node may ultimately be assigned, right? So this is the procedure. Anyways, let's think of an example. Okay, just give me a minute. There is someone waiting. Huh. So here we will quickly see alpha beta procedure. So how do we start? So we start with slideshow. My screen is visible, right? Okay. So at the first level, we keep alpha equals to minus infinity because it is the lower bound, and beta is infinity because that is the upper bound. And then we keep on pushing this value to the successors: alpha minus infinity, infinity minus infinity, infinity minus infinity, infinity. And when we explore this particular left subtree of 30, we find that you will get at most 30 from this thing. So you update this node's beta to 30, right? Now you
Sir,
push
how
this.
do you explore?
So at first beta will be 80, because you go to that subtree and you know that, okay, the cost here is 80, right? So your first beta will be 80, and then the next beta will be 30, and your alpha is still less than or equal to beta. So you will push this up,
Hmm.
right?
Hmm.
But in this is a max node, right? So here you will get a lower bound. कि I will get at least 30. The guarantees that I am now expecting is at least 30. That's why you put alpha as the 30
Okay.
and you push this to the node below. So your alpha will be 30, beta will be infinity in the first run. And as soon as you explore this 25, your beta will be updated to 25, right? Because that is the lower bound that you can get from here. So that is the maximum value that you can get from the here. So your beta will now be 25. So what essentially is happening is you have a path at the match node that is promising you 30, right? But at this min node you are seeing that I cannot give you more than 25. The maximum value that I can give you is 25. So exploring the remaining children of this 25 node is useless because I already have a better path, so I will prune this child. So formally we say that when alpha exceeds beta, we prune, right? So this is the first case where the pruning will happen. Similar case will happen in this right subtree where we will see that after getting the value 30 from here, if we go down, down and down, so alpha will be 20, beta 30, and when we go to the right subtree of this node, we find that okay, alpha is 20, but beta has now become 5, right? Because see, in this min node, after exploring this subtree, you are saying that okay, I will not give you more than 20. ठीक है? But at this min, okay, sorry, this is a max node, so I can give you at least 20. That is what you are saying because this is a max node, right? Now you go to the right subtree of this max node and you find that this child can guarantee you not more than 5, right? But for this max node I already have a sub path. I already have a path which gives me 20, so I will prune the remaining childs of this particular node. Is the idea clear? Is the concept clear or not?
Yes, sir.
Sir, you are exploring from left to right in this case.
Hmm. Yeah, this was anyways discussed in the lecture. I'm just giving a quick overview before we go into solving the problems. So here beta becomes less. So here beta becomes less than or equal to alpha, and we prune. Similarly, if you see this entire thing, so here after exploring the uh, tree, after exploring the subtree of this left subtree of this 15, which is a min node, you say that okay, I will not give you more than 15, but at the max node I already have a path which guarantees me 20. So I will prune all the entire, like I'll prune the entire right subtree. So yeah, this is again an example of alpha beta pruning. So let us see some questions here before we move further. Quiz week 5. Okay. Hmm. So you understood that this min max and all the alpha beta pruning, they are essentially depth first search mechanism, right? Because we are going in a depth first order, that we first visit an entire subtree and then we go to the next subtree and so on, right? So if which of the following is true about minimax algorithm with alpha beta pruning, assuming a two-player game where the only outcomes are win, loss and draw. So we are saying that an algorithm is complete when if there is a way to find if there is a way for the player to win, the algorithm will find it, right? So which of the following do you think would be true for minimax algorithm and alpha beta pruning? The algorithm is complete for a finite tree, the algorithm is optimal for a finite tree, the worst case space complexity is this, or and the worst case time complexity is this. So can anyone make a guess about this, since I'm telling
Um,
you that this is a depth first search
since
fashion,
since
right?
this is depth first search, the worst case complexity is of course b to the power n, and I think the algorithm is complete and optimal for finite trees.
Hmm. Yeah, so since your DFS is complete for a finite tree, but it might not be optimal for a finite tree. So we don't consider the notion of optimal, but we only consider the notion of complete. Hence, the answers are the algorithm is complete for a finite tree. The worst case is BM because that is the space complexity of DFS, and the worst case time complexity is B to the power m. That is again the time complexity of the that is the time complexity of the DFS. ठीक है.
This is Monte Carlo research.
हाँ ये तो ठीक है. It was discussed in the lecture, so if any one of you remember whatever was discussed in the lecture, so you can see the famous AlphaGo program defeated one of the best Go players. So it essentially used Monte Carlo tree search and deep neural network. We also
Sir, Monte Carlo research is in our syllabus, right?
yeah, Monte Carlo tree search is this random chance thing. Like I think I have slides on that also. Yeah, so this is like a game of choice or something.
No, so I don't think the Monte Carlo research was discussed in the lecture.
It was not.
No,
Okay.
sir. I think it is a far more complicated topic, Monte Carlo research.
ठीक
If
है.
it is in the, I'm not even sure if it's in the syllabus.
No, okay, so it might not be. Actually, I just remember this thing, Game of Chance and Monte Carlo also has the probability equal to it, so I just confused them. Anyways. Yeah, Monte Carlo is not in the syllabus. That's why it is just a question like that is taken from the slide itself. If you know what was discussed in the class, you can answer this question. Okay. I also need to see that what are there in the current week assignments, and I accidentally don't solve them. Yeah, what are there in the current week? Let me just quickly go over them. Which nodes are indicated? Yeah, 7 to 10 ice cream, vanilla. ठीक है. So these
Sir,
questions.
most of them are numericals,
हाँ,
so it doesn't matter.
हाँ, ठीक है. Okay, so this concept. So there is one more concept which we should do about alpha beta pruning is that if the nodes are not ordered in a correct order, so you might not utilize alpha beta pruning to its best. So here if you see this example which was discussed in the class also, like if you are at a max node that is 4, right? So 2 3 4, it has child 6 4 2, then it has 6 has child 6 5, 4 has child 4 3, 2 has child 2 1, then 3 has child 7 5 3, and 7 has child 1 3 7, 5 has 4 5, 3 has 2 3, and so on. So if you if you order the notes in such a way that you can prune in a better fashion, then your alpha beta pruning will also be of much help. Like in this case, like all the nodes are ordered in some sort of a reverse fashion, right? So here, like if you see 2 first, then you have to explore the entire subtree of 3 also, because it's a max node and 3 looks more promising. So you will enter this entire space, then you will explore the 4 space, and finally you will get to the maximum answer, which is 4. So in some sense you might end up exploring the entire space if you encounter bad moves. However, if your moves are ordered in such a way that you identify the good ones first and then go to the bad ones after exploring the good ones, then you might not need to explore a lot of nodes. So if we reorder these nodes, right, if we reorder these nodes in such a way that 4 comes as the first child instead of 2, right, and even if we reorder the nodes of 4 in such a way that we are able to get the best out of them, so we can in some sense optimize these kind of ordering. So this is what is done here. Like in 4, if we explore in a max node, that we find 4 is the best thing that we can get out of this subtree, then you might only need to explore the first left thing that you get, and rest all can be pruned, right? And similarly for this, you might need to explore the leftmost tree, and all the rest can be pruned away. So this is essentially this is something of a concept that you need, that you must understand, that if your nodes are arranged in an optimal fashion, then you might get the best out of the alpha beta pruning. So this question is on that line, that if I give you a min max search tree with a root node A, which is max node. Now A has three children, A1, A2, A3, which will be min nodes, and each AI has children AI1, AI2, AI3, and the backed up values to each of these Aij nodes can be calculated using these formulas, right? So now I wish to perform an alpha beta pruning. So what is the ideal order for maximum possible pruning, right? So here I have calculated these values, and I can show you the tree structure. So the tree will look like this, right? If I keep A1, A2, A3 intact, right? So for A1, as for the children of A1, the cost will be 456, and the computation can be seen on the left. Like A11 will be 3 times I minus 2, so I is 1, so I minus 2 will be minus 1, plus I cube in times j. So j is 1, I is 1 for A11. So here I is 1 and j is 1, right? And if you fill in this formula, you'll get 4. For A12, it will be 5. For A13, it will be 6. For A21, the cost of the children will be 8, 16, and 24, and so on. So this is your A11, A12, A13. This is your A21, A22, A23. This is your A31, A32, A33, right? So if I were to order this particular subtree in ideal fashion, so what I would do first is keep A3 as the leftmost child, right? Because if I get the bound 30, which is of A3, right? If I get the bound of 30, then I will only need to explore on I will explore one of the like I will explore the leftmost child of the next subtree, and I can prune the rest because they are giving me lesser values. They are giving me lesser values, so I will only explore the leftmost part, and after getting the values backed up from the leftmost child, I can clearly say that okay, I will get a value which is far less than 30, which is already guaranteed from A3. So I will prune the remaining childs and I will not explore them. So is this idea clear? Is the question and the way
Yes, sir.
of ordering the children, is this idea clear or not?
So can you like just let us see the question for a second?
Sure. Yeah. So this is. So first of all, tell me, did you understand the concept of ideal ordering?
Yes, yes, sir. At least I did.
What about the rest? Is there someone who did not understand the concept of ideal ordering? You can raise your hand. Okay. So the idea of ideal ordering is that you should order your nodes in such a way that you can prune, so that you get most pruning out of the alpha beta pruning procedure, right? So if you see here, if you see the ordering in this particular scenario, so 4 2 3 4 6 4 2 6 4 3 2 1, then the children of 7 are 1 3 7, the children of 5 are 4 5, and 2 3, and so on. So in each of this setting, if you see that until and unless you explore the rightmost child, you don't get the optimal value. See, in this mean level, where do you get the value 2 from? So that is backed up from the rightmost child every time. And you might the problem is that if you get this value at the rightmost corner, you will never prune anything on the remaining childs, or you will never prune anything in the 6 domain or 4 domain, right? So can we so the question that we pose is there a way to get a ideal, or is there any ideal ordering that we can use? given that we know the cost. So this is more like a concept level analysis, right? So if there is a way in which you can estimate the cost, and can you reorder the nodes in such a way that you get the most out of this pruning procedure, which is the core of the alpha beta pruning. So I can argue yes, you can do it. And how? See, what is the maximum value that you are getting? The maximum value that you are getting is 4. And from where you are getting it? Sadly, you are getting it from the rightmost child. And in the rightmost child also, if you see the path that I have to follow to get 4 is 4, 4, and 4. So in some sense, I have to explore the entire search space. So what I will do, I will just reorder the childs. So I will say that no, instead of exploring 2 first, I will explore 4 first by keeping it as my leftmost child. So here my leftmost child will become 4. Then between 2 and 3 you can keep anyone because it does not matter, because you will prune anyways the rest of them. So you will get 4, and then 4 will be backed all the way up here. And after that if you start exploring the search tree, so you will see that okay, from 3 3 3 in the min node I am guaranteed at most 3, whereas I already have a path that will give me 4, so I will prune the remaining childs. In that way I get the most out of the alpha beta pruning. If I reorder this 432, this 234 to 432 or 423, I will get the most out of the alpha beta pruning because I will prune many nodes. See, so that is what this question is asking. So what the question is asking is that you are given this configuration that you have children A1, A2, A3, and you are also given that each of the A1, A2, A3 has three children, AI1, AI2, AI3. Now suppose that the minimized tree computes the backed up values to the nodes using this formula AI j equals to 3i minus 1, 3i minus 2 plus I cube j, where this mod thing represents the absolute value. And now you wish to perform alpha beta pruning. So is there any ideal order in which you can arrange this A1, A2, A3 so that maximum pruning is possible, right? So I have just basically done the computation to show you what are the costs that you will find at each level. So for A11 you will get the cost of 4, A12 you will get the cost of 3, A13 you will get the cost of 6. For A21 you will get the cost of 8, A22 16, A23 24, and for A3 you will get 30, 57, and 84, right? So if I put A3 first, then A2, then A1, then naturally I will get most out of this pruning procedure, because as soon as I enter the A3 subtree, irrespective of whether I encounter A2 or A1 first, after exploring the first child itself, I can say that the rest of the subtree is useless, because I am already guaranteed a better path of cost 30, whereas A2 and A1 can give me 8 and 4, which is worse than what I already have. So I will prune the rest of the childs, right? So this is what the question is asking. Is there any ideal order? Yes, there is an ideal order, and the order is A3, A2, A1. So now is it clear?
But will the order of these sub childrens of children matter as well, right? For
That that
example,
that you
if
can order, that you can order on the in the least first, like that you can order in a least first fashion.
so we
That
don't have to
whichever has
write
the least
those.
cost, whichever has the least cost, since it's a min node, since A1, A2, A3 are min node, if you put the least cost as the first child, then you are guaranteed that you will not. Then there is no way that you will get better than this, right? Because it's a min node, and you are already keeping the one with the least cost as the leftmost child, which the depth first search will first explore. But in the question, it is just asking for A1, A2, A3. So for that, it is A3, A2, and A1. And if there are ties, then you pick, then you put the first lexiographically largest one as the correct one. So between A1, A2, there is a tie because it does not matter anyways. So you will pick A3, A2, A1 because A2 is lexicographically better than A1, is lexicographically greater than A1. So is this explanation clear?
Yes, sir.
Yes, sir.
Okay, good. And Anuj, I hope your question is answered. Because if there is a tie, then we pick the lexiographically largest one that is mentioned in the question. If two solutions are equally good, then pick the lexiographically largest one as your answer. Okay, so the next question is on the pruning part. So assume that we have the ideal ordering of the previous question. Let the number of children of A2 which were explored be E and the number of children which were pruned be P. Then what is the value of EQ plus P? So can anyone think, can anyone comment before I start with the solution? What would be the value? So
Sir,
E,
can you put that slide again?
sure, sure.
Solution slide, where you saw.
So A3, A2, A1 is the ideal order. The cost, and each of them has three children. So A3 has three children, A2 has three children, A1 has three children. Okay. So assume that this ideal ordering is followed, and we are talking about A2. So if E is the set, if E is the number of nodes that are explored, and P is the number of nodes that are pruned. So what is the value of EQ plus P? Would anyone like to make a
Uh,
guess on this?
Only one is explored. Okay, A3 is explored, and A2 and even are the pruned nodes, right?
No, no. See, directly A2 will not be pruned. A2 will only be pruned when you get the cost of A2, right?
Yes.
See, when you start with alpha beta pruning procedure, what will happen? So this will be the
A21
next
is
node.
explored, A22 and A23 is pruned.
Okay. Then you will have A3 here, then you have A2 here, and then you have A1 here. Okay. I'm just saying it can be A1 and A2 also, it does not matter. Okay, then there are three children of A3, there are three children of A2, and there are three children of A1. Okay. So for A3, the children ordering is 30, 57, and 84. Okay. And for A2, it can be anything. Let it be 8, 16, and 24. Yeah, it can be anything, but like I'm just keeping the least cost as the first because that is what this min node will ultimately return. And for A11, it will be 4, 5, and 6. For A1, it will be 4, 5, and 6. Right? So here it is minus infinity, infinity. Okay. Here it is minus infinity, infinity. Here also it will go minus infinity, infinity. Then once this is backed up, it will go minus infinity 50, minus infinity 30, right? Minus infinity 30. Then it will see the next child, it is 50. Okay, but it is a min node, 30 is still less than 50, so I will keep 30 and I will ignore 50. Then I will go again, right? I will see it is 84. Okay, it is 84. I will pick 84, but I will see that currently I have 30, so I will not take this path. So I'll back 30 to my 30 to my parent. So this will have 30 now, and now you go 30 comma infinity, something like okay, not this. So you will back down minus infinity, okay, minus infinity comma 30. Then 8 will become 8 will come up, right? It will come up to this min node, and you will say that this has now become 8, but I already have a path which has promised me 30. So I will prune this, I will prune the entire subtree that is there. So I explored only one and I pruned two, so my E is 1 and P is 2. So I was asked EQ plus P, which is 1 plus 2, and I got 3 as the final answer. So that's how I got 3.
So A2 is partially explored,
Yeah,
right?
see, you will still explore A2, but you will explore only first child of A2, because then itself you will get that if you maintain the ideal ordering, right? Then after exploring one child only, you will get the idea that since it's a min node, and at min node itself I got the first child as 8. Now, since it is a min node, I will in no way pick a child better than 8, right? Because it is a min node, right? But at the max node, I already have a path which has guaranteed me the cost of 30. So there is no point in exploring the childs of A2, the remaining two childs of A2. So I'll prune them. given that the ideal ordering is followed. That is the context that you have to remember, that we are indeed following the ideal ordering. Okay.
Okay, sir.
Hmm. We can move on now from this question.
Yes, sir.
Does anyone else have any question, or maybe I don't know? Okay, so moving on to the next one. So consider the following minimax tree. The values backed up to the nodes E, F, G, M have been given to you. Now you perform a min-max with alpha beta pruning. Okay. Okay, so let me just copy this image and I'll just paste it here. Then we can. Okay, cool. Okay. So we will go first from. So what are we asked? We are asked that, and close this. So we are asked that how many nodes would be pruned out. Assume we explore the nodes in lexicographically order. Pruned out means that the nodes were never explored. Okay, ठीक है. Cool. So first we will start with from A to B, from B we'll go to E. Okay, and so E 30, so B will have 30. Okay, so at B we have 30. Now 32 comes. It is a min node, so it will ignore 32. 34 comes, it will ignore 34. So 30 will be pushed to A, right? Then this will be pushed to C. Then we will go to H, which says that okay, I can give you 18, right? I can give you 18, but at max node we already have a path which says that I can give you 30. Okay, so there is no point in exploring these two. Is it clear why are we not exploring the remaining two childrens?
Yes, sir.
Yes, sir.
Okay, ठीक है. Hmm. So we don't explore these two. Then we go back up. Then we see 30 again, and we see 21. We see 21, and we say that okay, but we already have a path to 30. We have a path with cost 30. So 30 is less than or equal to 21, and we will prune the remaining childrens. Okay. So what is the answer? So the answer is 4, and the children's pruned are I, J, L, M. Okay. And what is the final minimax value which is backed up to the root? That is 30. Okay. Is the solution clear?
Yeah, yes, sir.
Okay.
Yes, sir. Yes.
Yeah, these this week's questions are very straightforward, but yeah. Okay. So next question is, in which situations would min-max tree not be the best algorithm in an adversarial game? So there is no opportunity to apply alpha beta pruning. The adversary is suboptimal. The search tree depth is not finite, and the action space is continuous. So I'll just tell you that if action space is continuous, then you cannot apply minimax search. But what about the rest three?
I think BCD is the right sounds. BCD.
Hmm?
BCD.
BCD.
Ad, if the adversary is suboptimal, then you can't exploit weaknesses. And if the search depth is infinite, then it will get stuck in loop.
So does anyone else not understand the idea of suboptimal? If so, you can raise your hand. Okay. So here, what happens is, if you know that your adversary is suboptimal, then at some point of time you can start exploiting its weakness. As who said S name? So what is your full name? I don't know. Okay.
Uh, you
Okay.
were asking my full name?
So as was correctly pointed out by him, that if your adversary is suboptimal, and if you have seen the lectures of the class, you might remember that if your adversary is suboptimal, then at some point of time you will know its weaknesses, and then you can exploit them yield to yield better solutions than what you might get. So if your adversary is suboptimal, your min-max tree might not be the best algorithm to use. And similarly, if your search tree depth is not finite, since depth first search itself is not complete, so you might not end up finding a solution. So that's why min-max search might not be the best algorithm. And action, if your action space is continuous, then also it is not good.
Sir, what's the meaning of action space is continuous?
So, okay, there is this concept. If you see in the book, I actually let me show you. So, action space can be continuous for some adversaries, which I'll show you right now. Uh, are there some examples? Let me see first because even I am not.
For example, in football, you can say that the speed of your movement and the force you apply is continuous.
Hmm. Hmm, forward pruning. ये कहाँ है?
Uh,
I am still an adversarial search on it. Stochastic games हो गया. I think that there should be some examples. I don't know. But yeah, you can consider like if you are playing some games where your state space is continuous, like if you are racing, for example, in that case, what is the pressure that you apply on your brakes? What is your speed that is continuous? Although it can be discretized at some time steps or something, but still it is some sort of a continuous thing. There might be some things on something or the other like. But it was discussed in the lecture that if it is continuous, like I think sir just made a small comment somewhere that
yeah, he made a comment on racing that in a race the action space is continuous, I think. But he also commented that in a race it's only one player game. So
hmm. Yeah, it was discussed in the lecture, but not with
Yes,
the.
sir, I'll go through it then. Okay.
So yeah. So your next question is assume that someone gives me a hint that the value backed up at root of a min max tree is between 1 and 5. Okay, so the least you are getting is 1, and the best you can get is 5, or it can also be the other way. So can I use this information to my advantage? So what will
yes,
you
sir.
do? So what
Yes,
will
sir.
you
If
do?
the value does not exist between 1 and 5, we can prune those nodes.
So set value of alpha 1 and beta 5.
Hmm. Yes, so you can set the value of alpha 1 and beta 5 because that is alpha is the lower bound and beta is the upper bound. Exactly. The moment beta becomes less than alpha, you prune. That is your condition. You know that your alpha is 1 and beta is 5 because alpha is the lower bound and
So alpha is the lower bound. It will be
beta is the upper bound. Yes, exactly. Okay. So consider a game. Now this is, yeah, okay. Before we go there, I'll just quickly go over this concept which was discussed in the class. So there can be certain games where some concept of chance can also be involved, right? So, for example, it can be rolling a dice. It can be picking a card, or like or you are, let's say, just doing some tosses or something like that. So in that case, you can use three kinds of nodes. So there is the standard max node, there is the standard min node, but a third type of node which helps you to engage in the chance space. So you put a chance node, and at every level that probability you so at every node you mention the probability of ending up at that particular path, right? So then in the class there was this example which was given that if you are at a max node, then there is a chance node, and the probability of taking the left path is zero point 0.4 and zero point 0.6, and just below the chance node there are min nodes because earlier you had a max node, so there are two min nodes, and then you go to from min node there are chance nodes and so on. So at some point you got to know that the values just before the chance nodes are 5 and 4 respectively, right? So at chance node what we gather is the expected value, right? So the intuition is simple that if you can take the two paths, one with probability 0.4 and 0.6, and you know the outcomes that you might get at those paths, so statistically you just return what is the expectation at that particular node, which is simply f of the probability of that particular event into the value of that event. So 5 into zero point 0.4 plus 4 into zero point 0.6, and you get 4.4 as the expected value, and that you push. So 4.4 here, 3.8 here. This is a min node, so you will pick 3.8. 3.8 here, 1.2 here. So at this particular node, you will return 3.8 into zero point 0.4 plus 1.2 into zero point 0.6, and similarly something you will get at the right node. It's right node also. So the idea is that at every chance node, you simply return the expected value. Okay. So we have this thing. We will just copy this and we will solve these questions. Okay, cool. And then we will end this session if there are no doubts. Let's see. Okay. Mm, I hope you can see the diagram clearly and there are no any issues as such. Cool. So let's start. So this is a min node and you have 4, 4, 5. So here you will get 4 as the minimum value. Here you will get 5 as the minimum value. Here you will get 1. Here you will get 1. And here you will get 3. Okay. So what is the value that you will get at this node? It will be 0 0.2 into 4 plus 0 0.8 into 5, which is 0 0.8 plus 4, that is 4.8. So here you will get 4.8. Here you will get 1 because there is only one path and no branching, so this value will be here. And here you will get 0 0.9 into 1 plus 0 0.1 into 3, which is 0 0.9 plus 0 0.3, which is 1.2. So here you will get 1.2. And since this is a max node, it will pick 4.8. Okay. So this is 4.2, 4.8, 1.2, and the max node you get 4.8. So were these I think these computations were clear, and I hope there are no questions. And the answer that we get is 4.8, which is also given here. So was this computation clear? If not, just raise your hand, or you can speak up. Okay. So since there are no questions, okay, we will just put this here. And the next question is, if you think carefully, alpha beta pruning is possible in the best case. So what is the least number of min nodes that needs to be fully evaluated? Okay. So what are the least number of min nodes that needs to be fully evaluated here? So can anyone make a guess? So out of all these min nodes, which ones do you think would still need to be explored?
Didn't understood question, sir. Can you repeat again?
Okay. So you understood this part, right? Like, so
Yes, sir.
essentially we solved this and we found that at the max node, the final value that we will get is 4.8. That part is clear. So the question is, if you think carefully, alpha beta pruning is possible in previous question. In the best case, what is the least number of min nodes that need to be fully evaluated? Can you wager a guess that what is the least number of min nodes that you would still need to evaluate? So do you think if we don't explore, can you think of something that, okay, if I drop this, my answer will not be
Sir,
affected,
four
but
node. I think four node.
but how can you say it is four nodes? What would be your?
Sir, both the two branches of right.
Hmm. See, at you will need to explore this, and you will anyways explore this because there are no childs to this. So one, two, three, and you will explore just any one of this, and you can say that okay, I already got a path of 4.8, and your expectation after exploring any one of them cannot be more than 4.8. So we can just say that we can just prune this child, for example, and just say that okay, this does not work out. So one, two, three, four. These are still the least number of childs that you might need to explore, and that is the least node.
Again, sir, please.
Hmm?
No, I didn't understood the explanation.
Okay. So essentially, what the question is saying that, do you think here you can apply alpha beta pruning? Let's first understand that. Can you think that here alpha beta pruning can be applied? First answer that. Like, do you think alpha beta pruning can be applied in this particular scenario?
How will we apply?
Hmm?
How will we apply an alpha beta pruning in this case?
See, what I can tell you is that even after picking the best move, the payoff was just one.
Sir, can,
Hmm?
sir, are we pruning this parent node of 345 as well?
Mm-hmm.
Sir, but what if, for example, if we prune that 345 loan, and what if instead of 345 there is a positive infinity, and positive infinity? Let's say, like best worst case scenario, and the children of this three is positive infinity, positive infinity, positive infinity. Since we did not explore this node, we don't know what's the value. So let's say,
That's why
and
we are just
and
making a
this
comment on the least node that you might still explore, not the this is a lower bound, not an upper bound. That even if you do alpha beta pruning, you will still need to explore these many nodes. Exploring this or not, okay, but you might still end up exploring at least four nodes. See, what is the least number of min nodes? That is the question, not the max number. It is the least number. I'm just wagering a lower bound. See, left subtree, anyways, you have to explore completely because then only you will get a better estimate. Like you will have a firm estimate. After that, in this one there was only one, so you say that okay, I will pick this. But in these two, this probability difference is such that this event is much more likely to happen. The left one is much more likely to happen than the right one, right? Because it is 0.9, 0.1. So if this event has a very less has a very less payoff of one, so you can say that okay, I might not be interested in exploring the right subtree. This is just a lower bound that okay, I might not explore. That's why I'm just saying that okay, I'll still need to explore at least four nodes.
So, should we consider that it is saying the best case? That's why we are taking that 0.9 is the best case.
Wait. So in this you have like in the scenario that is most probable, that is not even giving you value close enough to what you already have. So here it was 4.8, right? Here it was 4.8, and the payload that you get from here is just one.
Got it.
So you can just think of this as pruning. Although they are not saying that you will prune. Okay, it is just a thought process. Like, can you think of this case? If yes, so what in best case, what will be the least number of min nodes that would still need to be fully evaluated? That is what we are asking. So we are saying that okay, I might not consider evaluating this because in the one that is highly probable has much less payload
sir,
than.
hello.
Uh-huh.
Sir, can you scroll down a little bit?
Can you?
Scroll down, please.
This one.
No,
No?
no, no, no. The question.
Uh-huh.
If you think what, so we are trying. We were talking about the least number of minutes. So we are trying to maximize the pruning, right, sir?
What is the least number of min nodes that need to be fully
So we
evaluated?
are maximizing the pruning.
So we are saying no, that is the least number of min nodes. We are not saying anything about pruning. We are If we are saying this is the least number, that means that okay, how what is the upper bound on
No,
the on the pruning that you can put.
exactly right, sir. So we are pruning this extreme right subtree, right? Extreme right tree, 3, 4, 5.
Yeah, I'm just saying that because in the best case, like in the case that is highly probable, the payload that you are getting is much less than what you have.
But how can you say that? For example, if there is infinity in those three cases, then
That
it will show up in the results, sir.
that's why
So you
that's why
can't prune these nodes.
it is a game of chance only. So that if even if it, like, I can understand your concern, and I'm acknowledging it, but since it is a game of chance, so 0.9 and 0.1, right? These two.
But sir, the professor said that when we prune, we make sure that the answer should not never differ. Like it's not like the alpha beta pruning is less, less in any case
No,
will be
anyways,
less
what you are
suboptimal.
pushing, anyways, what you are pushing is an expected value. You are not pushing an actual value. If you think carefully,
Yeah,
you are,
but if there's infinite values in the 3, 4, 5, then the expected value becomes infinity as well. Point 1 times infinity,
अच्छा
infinity,
वैसे, हाँ,
and then infinity will get pushed over. So when we do alpha beta pruning and when we don't do alpha pruning, the answer should be the same. But in this case, it's not the same if we
ठीक
prune
है,
these three nodes.
okay, okay, okay. So the second argument that I can give you is, uh, let's think of this scenario that we studied. Okay, I think I understood what was the problem. Let us think of this scenario. Good, bad, and good cases for alpha beta pruning. ठीक है. Here we saw that you can get the best out of alpha beta pruning if you maintain the ideal order. Okay, with me so far,
Yes, sir.
है ना? अब इसमें आप देखो, अच्छा ठीक है, आई अंडरस्टूड, ओके. अब
So
इसमें आप
for
देखो, if
even
you do
then,
the,
we have to
if you do
reorder
the
this
ideal
subtree.
ordering, if you do the ideal ordering, then you only need to evaluate these two, and you need to evaluate these two, right?
Yes, sir.
This might still be a case, might not be a case, but you can just prove this one.
Why, sir? Why? If there's an infinity in this node, instead of one, there's an infinity, and this
But
infinity gets transferred over, that will be the answer.
that
If we
you can
prune
argue
this,
for everything. That's why we are saying that if we know what are the values, we know what are the values. Okay, I
if you
have
know,
backed it
then
up
there's no point
everything.
in pruning.
I have backed up everything. Okay, so if you follow the ideal ordering, right, then you will explore this 4.8, its children, which are 4 and 5, and you will explore 1.2 and its children, which are 1 and 3. But this you might not explore.
And so one more thing, it's just a evaluation function result, no? So not even the end of the game. That's why we are letting go 0.1 probability perhaps, because eventually min-max is all about
See,
having a
that also
evaluation function
that
and
also we
having
can think.
value of particular
That
point.
also
And
that also we can think. But the question that he has posed is also correct. That even if you do alpha beta pruning, you should not you should not end up with a solution that is less.
That is different from the otherwise.
Hmm.
Like the professor said that the alpha pruning, beta pruning does not change the answer, never changes the answer. But in the pruning which we just did, the answer changes.
See, I am understanding your point, but you should also understand that this is a game of chance. There is a chance factor also involved here, right? So if an event is highly probable, you try to understand my stand also. See, here it is saying that it is 4.8, right? But it might so happen that it just goes in this with chance 1 and give you 1. We are just backing up the expected value. That is what I am saying.
Sir, the thing is, we are trying to justify the answer, sir, perhaps, just like we did in the
Yes,
case
sir.
of fourth week
See,
assignment first
if you
question,
think from
sorting
the
order.
argument that I was trying to give earlier, that it is a game of chance kind of scenario, right? So you might sometimes also end up with the 0.2 branch, where you will get 4, which is less than 4.8. Sometimes you might end up with 0.8, and you might get the 5 1, right? But here, what I think is, even at the branch which is highly probable, it has the value just 1. It gives me just 1. So I can prune the one which is extremely less see, 0.9 and 0.1 are two extreme cases, right? The probability difference is so high
Sir,
that
but
this
we
event
only
is highly probable.
sir, but
And
we are only pruning it because we already know that this is three. For example, if there was 100 here,
I
like
understand. I understand your point that it is 100, and you will back up here 100 also. I understand your point. I'm not saying that you are wrong. I'm not saying that you are wrong or anything. I'm just saying that in the current scenario, see, alpha beta pruning, they are saying only for this current thing. They are not saying in general. They are saying in this current scenario, do you think alpha beta pruning is possible? They are clearly saying in the previous question only. They are not saying in general. In this previous question, if you just think, like at 0.9, I found that okay, my payload is 1. So at the best case, you are getting this value. So I can just think of pruning the right subtree and not evaluate this min node. That is something which you can think, right? Because anyways, there is a factor of chance involved, which is what I am saying. So it is very less likely. See, this 0.1 is much less likely than 0.9. And most of the time, since it is so biased, most of the times you will go here only. But anyways, you found that my expected expectation on the left is higher, so I will not even bother going there. Which is true only for the current scenario. Which is true only for the current scenario.
Sir, just in case, then if the leftmost node would have been in the between and the 0.2 ones would have been on the right side, then we might have
Then
also
you can
pruned
say
that
that,
also.
then you can say that there are no cases of pruning which I see. Then you can say that no, there are no cases of pruning which I see.
Mm.
They are asking only in the context of this current question. They are not asking in general or anything, because I don't think in the book also they have discussed a variant of alpha beta pruning in this setting.
oh, they did. This is this is the oh, sir. Uh, yeah, this one. It's the same.
No, it's not the
Yeah,
same.
it's same. We are yeah. Those circles are the expected node, and we are multiplying. This is exactly the same.
Mm-hmm. नहीं तो क्वेश्चन क्या है इसमें ओके लेट मी जस्ट गो ओवर दिस इसको फिगर को मेंशन कहाँ किया है फिगर 5.12 5.12 But in fact, the presence of chance nodes means that one has to be careful about what the evaluation means. With an evaluation function that assigns 1, 2, 3, 4 to its to the leaf moves, A1 is the best.
A1 is not defined in the diagram.
अन्य A1 ये हो गया ना ये पाथ A1 हो
Okay,
गया
okay.
with values 120, 330, 400, A2 is best. वो बस वही बोल रहा है कि अगर आप ऐसा कर दो. Hence, the program behaves totally different if we make in change of the scale of evaluation values. It turns out that toward the sensor, there must be linear transform, must be a positive linear transformation of the probability of winning from a position or generally of the expected utility. This is an important and general property of situations in which uncertainty is involved, and we discuss it further. So they don't comment on this part of pruning. That is what I was saying. Like I did not see anything, any such of pruning in this tree. That's why they're just saying that in the current question, can you think that pruning can happen? And anyways, they don't provide any solid answer to this. So my take is this: like you can disagree, and you can find like a good solution online also. But yeah, my stance is that the highest probable move is the giving you just one, whereas you did find a better move here, which was at 0.8 you get 5. So it's better going this direction and pruning this off. So this will be my final take on this. I can search more, and I'll get back to you in the next class on this one.
Sir, you're going to uploading this as well, right?
Hmm?
You're going to upload this, right?
Yeah, the slides and everything, the video and everything will all be available on YouTube in the next 1 or 2 hours. I'll upload everything.
Okay, sir.
Hmm.
Thank you,
But
sir.
yeah, I'll get back to you with this one on in the next class for sure. Hmm. But I think this computation was still easy. That what is the value backed up? It was very straightforward. That you just take the expectation and you push it up the hill.
Okay, sir, can you like just show the 10th question again so that I can just check the video?
So the 10th question is, if you think carefully, alpha beta pruning is possible. What is the least number of min nodes that needs to be fully evaluated? That is what being asked.
Okay, sir.
And I can think from both the views that the first is this, and the second is if you order the nodes in the ideal fashion, then you might prune the one with the this one. But that again is a thing for discussion. But that best case thing is throwing me off guard. Like, what do you mean by the best case here? In the best case, what is the least number of min nodes that need to be fully evaluated? Hmm. Okay, so I'll leave you with this, and if there are any questions or anything other than this one, maybe we can discuss. Or if you have any questions on the lecture or slides or doubts that you did not understand, you can ask. If not, then we can end this session.